Okay, Pure 4, Chapter 6, Integration. So, a really huge chapter that we're going to go through, and we're going to go through this step by step. Okay, as we know, in the chapter, we're going to look at 4 different types, or 5 actually, different types of integration. So, we are going to look at integration, finding the area under the curve using parametric equations, or the volume, okay, really simple. We're going to look at integration by substitution, which some of us would have touched upon when we did the chain rule and differentiation. We're going to look at integrating partial fractions, so you need to make sure your partial fractions is up to date. Integration by parts, probably one of my favourites. We're not going to use this formula. I have a magic way to do this. And then solving differential equations. This is going to help us finish off the questions that we just looked at, rates of change, in the previous chapter. Okay? So, integration with parametric equations. Right, we've got these 2 parametric equations. We've got x equals t squared and y equals t plus 1. So, we know to find the area under the curve, we want to determine the integral of y equals with respect to x. However, the problem that we have is we know that our integral with respect to x, we don't have that right now, do we? Okay, so one of the things, we could rearrange this to get y equals in terms of x, and then integrate it this way. However, we found with the more difficult functions, this is not going to work. So, we want the integral of y with respect to x, right? However, do we have y? Yes. What is the integral of y with respect to? T. So basically now, I'm going to show you why we're going to do what we're going to do. Now, if I integrate y, this is with respect to t. However, what do I want it with respect to? Okay, if I want it with respect to x, what would I then need to multiply by? dx dt. Because then this is going to cancel the dt's. Okay, so how this works is, are we ready? We are going to integrate y with respect to t and then multiply it by the differential of x with respect to t, because in theory this is then going to cancel out the dt's. Yeah. Do you see what's happened here? Mm-hmm. Magic. So, the best way to do this then is to write it as the integral of y multiplied by dx dt with respect to t, because then in theory that cancels out, right? And that's how we get the integral of y with respect to x. So, step 1, we know what y is. Okay, if we were to integrate, so dx dt, okay, dx dt is what? Yeah, if we differentiate t squared, we get 2t, okay? So, what we now need to do is we've differentiated, so we've got the integral of y with respect to t is t plus 1 multiplied by dx dt, which is 2t. Now, this is going to be with respect to x, okay? We need to multiply first, then integrate. Okay, so we're going to have, this is then the integral of 2t squared plus 2t with respect to x. We're now going to integrate this, 2t squared integrated, 2 cubed, 2 over 3, plus t squared.
Why is it with respect to x?
Because we want to integrate y with respect to x, to find the area bounded by the x and the y-axes. Right, now we have this. We have our bounds, x equals 0, x equals 3. What are we going to do to find t?
Square root.
Square root. So the reason is because x equals t squared, so t equals root x. So to find our limits of t, we're going to get t equals root 0, t equals root 3. and then we're going to have between root 3 and 0. So now we're going to have 2 over 3 lots of root 3 cubed plus root 3 squared minus 2 over 3 lots of 0 cubed plus 0 squared. We know this is going to cancel to become 0. Right, so now we're going to have root 3 times root 3 is 3 times root 3 is 3 root 3 times 2 over 3 is 2 root 3 plus root 3 squared is just 3. So there's our answer. And then units squared. Right, so we're going to run through this question again one more time, slightly differently, okay? And we're going to run through it down this side. So, if we have a following pair of parametric equations as such, we're used to seeing these, aren't we? And it then asks us to find the area bounded between the curve. We know from pure 2 that if we need to find the area, we need to integrate between two numbers with respect to x. We integrate y between two numbers with respect to x, and then what we do, if this was a 4 and this was a 2, we'd integrate it, we'd substitute in 4, and then we'd minus when we substitute in 2. Okay, so this is a quick refresher. Happy with this? Okay, now, how do we apply this to this pure 4 content? We still need to integrate y with respect to x. However, this time, to integrate y with respect to x, we have to have this in the function y equals. And it has to contain only x's. This is really difficult to do with what we've been given. So the best way to now do this is to know that we can integrate y with respect to t, can't we? Okay? Because y is in terms of t. However, we want dx. Now, theoretically, we know that the only way to get dx is we could differentiate x with respect to t. dx by dt. So in theory, these two would cancel out and we're left with y by dx. This is why it works. This is a bit of the background. However, all you need to know is this. Whenever we're finding the area bound between the curve with the parametric equations, we need to integrate y multiplied by the differential of x, and our limits need to be in t's. This is all we need to do. So how does that look? Step 1, okay? We need some bits of information. We need our new limits and we need the differential of x because we're already given y in the equation. So, if x equals t squared, what is dx by dt? 2t. Okay. Our limits are given to us in the question, x equals 0 and x equals 3. So if x equals 3 and x equals 0, I need to use the equation x equals t squared to find what t equals. When x equals 3, I have 3 equals t squared. So therefore, what does t equal? If 3 equals t squared, t equals square root of 3. And if 0 equals t squared, what does t equal? 0. So now we have our new limits. Do we have our new limits? Yes. Do we have our differential? Yes. So now we need to integrate between our new limits of, now remember, when x equals 3, that was our upper limit, that is correlates to t equals root 3. So we need to put this at the top. When x equals 0, that correlated with our bottom limit, so 0 goes here. Okay? So now, what we have is our y, what was our y? T plus 1. Is t plus 1 multiplied by 2t, and then we are going to integrate this with respect to t. So I need to simplify this now. So we're going to have the integral of root 3 between root 3 and 0 of 2t squared plus 2t with respect to t. So now from here, this is basic pure 2 integration now. Okay? Getting to this part, this is where the pure 4 skill lies. So then once we've done that, we can go back and have a look at, okay, now we substitute in once we integrate, and then we're going to have our answer. It's this part, once we do a few questions, we'll understand it slightly better. Okay, so step 1, let's read the question, and we know straight away it's parametric, okay? It wants us to find the area, so we know we're going to have to integrate. So we're going to integrate. We're going to do the integral of y multiplied by the differential of x with respect to t. Okay? This is what we're actually going to do. So, first of all, we're going to differentiate x. So if x equals, and I'm going to expand this out, t plus t squared, my differential of x with respect to t is 1 plus 2t. Okay, before I forget, I'm going to change my limits. Okay? So I need to find out when x equals 0, what does t equal?
Negative 1 and 0.
Negative 1 and 0. Okay? And when x equals 2, what does t equal?
Negative 2 and 1.
Negative 2 and 1. And how are you finding these out? It is a quadratic equation. So, when x equals 0, we're going to have t squared plus t equals 0. When x equals 2, we're going to have t squared plus t equals 2. So we have two quadratics. If we solve the first quadratic, we know now, in this case it was better to have it in factorized form, that we're going to have t equals 0 or t equals negative 1. Can you tell me why we would reject t equals negative 1? Yes, because in the question it specifically says that t is greater than or equal to 0. Okay, then for the second quadratic, t squared plus t minus 2 equals 0. When we factorise this, we're going to have t plus 2 and t minus 1. So our t is going to equal negative 2 and our t is going to equal positive 1. Why would we reject the negative 2? Yeah, because t is greater than or equal to 0. So the only ones that we have is t equals 0 and t equals 1. Okay, so now we have our limits. Now for our integration. We need to integrate y, which is 1 over 1 plus t. Okay, we're going to multiply this by our differential, which is 1 plus 2t. And then we're going to differentiate this. Okay, so we're going to have the integral of 1 plus 2t over 1 plus t between the limits of 1 and 0. Okay? Oh no, wait there. Guys, have I actually figured out x is 0? No, I figured out what t was. Sorry. We haven't figured out the actual limits, have we? We've solved for t. Yeah, we didn't finish off this. Right, so we know that x equals t squared plus t. Okay? So, what does... Oh yeah, we have done it now. Yeah, it is between 1 and 0. We solved it for when x equals 0 and x equals 2. Okay then, so... Now, what do we do? How are we going to integrate this? 1 plus 2t over 1 plus t. How are we going to integrate this? Okay. Some of us are saying learn, some of us are saying other stuff.
Easier to differentiate. They use substitution.
Okay, does anyone remember this is in fact a top-heavy fraction? A top-heavy fraction, for example, 7 over 5 is top-heavy. Why is this top-heavy? Yeah, because the denominator is greater than the numerator is greater than the denominator. However, this is in chapter 1, algebraic fractions. Within algebra, if the power is the same on the numerator as the denominator, this is also classed as a top-heavy fraction. So step 1, we need to sort this fraction out. Okay, we need to sort this fraction out before we integrate this, because currently we don't know how to integrate this yet. We will learn this further on in the chapter. So,
Can you do it like you know how we did integration by assumption?
okay, so if we want to, make this easier for us to integrate because we don't have the skills right this moment, we can do I'm silly Billy. Okay, so if we're dividing by 1 plus t, I'm going to change this to t plus 1, and we have 2t plus 1. Okay, 2t multiplied by what? T multiplied by what is 2t? 2. Okay, then we're going to have 2t plus 2. So then 2t minus 2t, it's going to be 0. 1 minus 2 minus 1. So that means, okay, that this integral can now be represented between 1 and 0 of 2 whole ones, remainder 1. So minus 1 over 1 plus t. We have now split this fraction into partial fractions, and all we used was I'm silly Billy, which is long division. Okay? Are we now able to integrate this? Yes, we can. So here we go. Integration of 2. 2t. Integration of 1 over 1 plus t.
Minus ln 1 plus t.
Minus ln of the modulus of 1 plus t. Now we would divide by the differential of the bracket. However, when we differentiate the bracket, it's 1 anyway, yeah? So there we have it. So now, if I substitute in 1, I'm going to have 2 lots of 1 minus ln lots of 1 plus 1 minus 2 lots of 0 minus ln lots of 1 plus 0. Okay? So now, we're going to have 2 minus ln lots of 2 minus, this is going to be 0. So minus minus now becomes plus ln of 1. So we know that ln of 1 is 0. So our answer is 2 minus ln of 2 units squared. Okay, so this is an exam question. Now there's some helpful hands here. Okay, this is 10 marks. This is a 10-mark exam question. Off you go, 10 minutes. Right, part A. It says, show that A has coordinates 0, 3. So A has coordinates 0, 3. What can you tell me about A? A is on the y-axis, so that means x equals 0. So really simple. If x equals 0, we have two equations right now. We're going to use this equation. So x, instead of writing x, I'm going to write 0, equals 1 minus a half t. We're now able to work out what t is. So we're going to have minus 1 equals minus a half t. So t is going to equal 2. Now we know that t equals 2. I'm going to substitute this into y equals, because we want the y coordinate, right? So y equals 2 to the power of t, which is 2, minus 1. So y equals 4 minus 1, which is 3. Therefore, 0, 3 is the coordinate. So, it then says, find the x-coordinate of the point B. So, for the point B, can someone tell me, what do we notice about the point B? It's on the x-axis. What do we know about the x-axis? If it's on the x-axis, we know that y equals 0, okay? So y equals 0. This is just common sense here. Now, if y equals 0, that means 0 equals 2 to the power of t minus 1. So 1 equals 2 to the power of t. Now, if I wanted to, I could do some fancy logs here, okay? Or I could just use my brain, and I know anything to the power of 0 is 1. So t equals 1. Come on, guys, it's basic. Okay, let's say, though, you're in the exam, right? You're super stressed, and you forget the basics. Yeah, you forgot how to add. And that's fine, it happens, right? You forgot that 4 to the power of 0 is 1. You forgot that 5 to the power of 0 is 1. You forgot that x to the power of 0 is 1. Let's say you just forgot everything you ever learnt in maths, okay? Shall we have a look at how we would do this using logs? Just in case. So, if 2 to the t equals 1, this is the same as saying log to the base 2 of 1 equals t. If you put log to the base 2 of 1 into your calculator, you will get 0. Also, there's that log law, if we remember. Log to the base a of 1 is always 0. Another law that we learn, of course, right? Okay, so now we know what t equals. I'm now going to substitute this into x. So x equals 1 minus a half lots of t, which is 0. So x equals 1. So our coordinate, x coordinate for the point B is in fact 1. So our point B is 1, 0. Okay, so I can even just put 1 here. I might even put a 3 here. Okay, perfect. Right, the next part of the question says, the region R is shown shaded in figure 2 is bounded by the curve C and the line x equals -1 and the x-axis. Use integration to find the exact area of R. Okay, so what's going to happen is we're going to integrate between 1 and -1. Okay, so far, this is what we're going to integrate between. However, our 1 and -1 is what x equals currently, isn't it? So we need to change our limits to find what t equals. Okay, so step 1, we're going to change limits. So x equals 1 minus a half t. Okay, so what does that mean? It means x minus 1 multiplied by -2 equals t. I've just rearranged this equation. Someone check I've done it right. -1 times -2. Everyone happy? This is what t equals? Okay. So now, if x equals 1, I get t equals 0. When x equals -1, -1 minus 1 is -2 times -2. I get t equals 4. So actually, I need to integrate between my new limits of 4 and 0. Okay, now remember, I need to find out what y is and multiply this by my differential of x. Okay? And then I can integrate. So now I have x. I'm going to quickly do the differential. So dx by dt is, what's 1 differentiated? 0. What's minus a half t differentiated? Okay. So now I need to integrate between 4 and 0. My y is 2 to the power of x minus 1 times negative a half with respect to t. Okay, so I'm just going to simplify this before we start integrating. So, sorry. It does matter, 2 to the power of t. Okay, so this then is going to become negative 2 to the t over 2 plus a half. Okay? Now, does anyone know negative 2 to the power of t over 2? We could actually simplify this. Remember, this is 2 to the power of 1, right? And if we divide, technically, this is negative 1. So it's 4, 0, minus 2 to the t minus 1 plus a half. Okay? So, now I can integrate these. You right, boys?
He said there was negative 1.
Yeah, it's t minus 1.
Here is the negative 1. So, how are we going to integrate this? How are we going to integrate this? We have this rule here, the helping hand. Okay? Now, I think we're given this in the formula sheet, by the way. So, 2 to the power of x, and currently our x is t minus 1, yeah? Equals, so we're going to get, if we use this, so we're going to have 2 negative 2 to the power of t minus 1 over ln of 2. The integral of a half is a half t. This is going to be between 4 and 0. Okay, so let's substitute in 4 and 0. So we're going to have minus 2 to the power of 3 over ln of 2 plus a half lots of 4 minus 2 to the power of 0 minus 1, which is minus 1 over ln of 2 plus 0. Okay, so my only concern is, we're going to do the power first, then do the negative. So I'm going to have minus 8 over ln 2 plus 2 plus 1 over 2 ln 2. Right? So minus 8 over ln 2 plus a half ln 2. What's minus 8 plus a half? What's minus 8 plus a half? It's not difficult. 15 over 2? What's minus 8 plus a half? Yeah? Negative 15 over 2 ln 2, yeah? Plus 2.
Yeah, I got that.
Brilliant. Now, the mark scheme has a different answer. The mark scheme has positive 15 over 2 ln 2 minus 2. Can anyone tell me where the mistake is? Now, this mistake was completely intentional, genuinely, and no one picks up on it. Okay? The signs, not quite. Are you ready for this? It's going to blow your mind. If we have 0 and 4 here, why did I change it to 4 and 0?
Because you have to do the bigger number minus the smaller.
Well, this is what we've been led to believe, but this is not true. However, However, when we are looking at parametric equations, we need to keep it exactly in the order we get it. We need to keep it in exactly the order we get this. Guys, if you spot mistakes, you need to call it out. Because I was just going through this. I've written it so many times to see if anyone would spot it. Okay, so this is we're doing this minus the other box. Okay? Everything else is perfect. Please watch out for that classic mistake. On the examiner's report, I think on 1 year, for this one, I'll need to find out exactly what percentage of people got this wrong due to that. I think it was something, I think everything was right. I think maybe it could have been 60 or 55%, which is quite a lot really, isn't it? So, volumes of revolution. Now, we know that to find the area, okay, between b and a of a function y with respect to x. This is what we do, right? And we know that y is our function, x is our a, and x is our b, and the x-axis. So why does this happen? Because technically, we're finding the area, okay? We're doing strips. It's like the mini trapezium rule, essentially, yeah? Now, when we do a volume of revolution, okay, there's a few things we have to think of. If you think, on the next slide, it says click on this, and if you go onto the Dr. Frost website, you're able to click on it. But imagine, if I want to do this in 3D, right, what's going to happen is this. I'm going to get, imagine if I get this string, and I go all the way round and back to here. What am I drawing, essentially? Basically a circle. Yeah? Okay? What is my radius here? My radius is my y axis. Okay? And then what do we know about area of a circle? Pi r squared, isn't it? Okay, perfect. So, we're going to come to the formula now. So can you see here we've got these strips that then go along. So we want to then do that. So therefore, our radius we know is our y. So we're going to integrate between, instead of saying pi r squared, we're going to have pi, the integral between b and a of y squared with respect to x. Okay, this is where it comes from. We're going to speak more about that later. It's just a little insight until we get started. So then, first of all, we are going to write the formula down. If we're looking at volumes of revolution, we're going to write this down. So we know it's pi, the integral between our bounds of y all squared with respect to x. Okay, we need to square it before. We need to square it before we integrate it. Okay? Are we ready? So the region R is bounded by the curve of the equation y equals x. So the x-axis and the lines x equals 0 and x equals 2. Find the area of R. So first of all, it wants the area. How do we work out the area? We're going to integrate between 2 and 0, x with respect to x. When I integrate this, what do I get? X integrated?
1. Oh, wait.
X squared divided by 2. I think all of you differentiated in your head then. Right, and we're going to do this between the limits of 2 and 0. So when I substitute in 2, I'm going to have 2 squared over 2 minus 0 squared over 2, which is going to equal 2 units squared. Okay, this is pure 2 right there. Okay, then it says find the volume of the solid formed when the region R is rotated through 2 pi radians about the axis. Whenever it says it's been rotated through 2 pi, essentially we know it's going to be involving pi, and when it's been rotated through 2 pi radians about the x-axis, does anyone know what that actually means? So it's 2 pi. So this is potentially saying we're going about the x-axis. It's literally saying we go 360 degrees around it.
So is the circumference?
Okay, so it's basically saying we are going to form a circle, essentially, because a circle has 2 pi or 360 degrees. This is basically what it's saying. So this is proving what I've just showed you, right? Imagine like our x-axis goes through here. Here was our original point. It goes all the way around. So when it says it's rotated 2 pi, it's the same as saying rotated 360 degrees. Yeah? Just make those connections. Sometimes they're going to throw you off with the words. However, literally, we've just explained this, okay? So we know the formula when we're looking at volume is pi times our integral between the limits that we were already given of, what is our y? What does y equal? X. So in this case, x squared. Okay, sometimes you might want to do x squared, and then before, because it's not always going to be just x, is it? Okay, this is an easy example. So, step 1. We leave the pi on the outside. We're just going to multiply our answer by pi at the end. Okay, we're going to square our function with respect to x. Okay, so now we are ready to integrate as normal. Getting to this stage was the hardest part. So, how do we integrate x squared? Please don't differentiate. Come on, let's integrate. Increase the power by 1, divide by the new power. So we're going to have x cubed over 3 between 2 and 0. Now, with this pi, I want you to really take it completely out the bracket, right? You are going to multiply the final answer by pi. So forget about pi for now. So now what I'm going to do is I'm going to have between 2, I've got 2 cubed over 3, minus between 0, I have 0 cubed over 3. Now, I know what you're thinking, Miss, this is 0. The problem is sometimes when I stop writing and substituting in with 0, people forget that we're actually minusing this part. I know it's 0 cubed over 3 is 0. However, sometimes people assume 0 would then give us a negative, would then give us a 0 solution. Do you remember in the previous questions when we put 0, we ended up, because it was something squared plus a number, we ended up with that number, didn't we? Please always show you're working like this. So important. So, 2 cubed over 3, and remember this is all going to be multiplied by pi at the end. So 2 cubed over 3 is 8 over 3, minus 0, all multiplied by pi. So then this is going to give me 8 over 3 pi units cubed. Okay. So the pi is because you know area of a circle is pi r squared. We've then essentially we are going to look at how we prove this later. But what we've done is because we know that area is just the x, okay? We know that to get volume, we would then square this and multiply it through by pi, okay? All right? We'll come back to why this works later. For now, this is what you need to know. This is the formula. Let's do this. So, I want you to test your understanding. You're going to do the same, but this time it's for sine of 2x. Give it a go. Off you go. Okay, so for part A, we just need to find the area. So we're going to do this as normal between pi over 2 and 0 of sine 2x with respect to x. Okay, so this is just what we normally know how to do. So, how do we integrate sine of 2x? We know that we have sine, cos, minus cos. Sine integrates to minus cos. This is going to become minus cos of 2x. And then, when we're integrating this, we need to divide by the differential of the bracket. So in the bracket is 2x, so I need to divide by the differential of 2x is in fact 2. So now I'm going to substitute in pi over 2 and 0. So I'm going to have minus a half cos of 2 lots of pi over 2 minus a half cos 2 lots of 0. Okay, so you can see here I've substituted everywhere there was an x, I've substituted in my bounds. Now, so cos of pi is cos shift pi is -1. So this is minus what? Minus a half times minus 1, which we know is positive a half. Cos of 0 is 1. So I'm going to have minus a half times 1, which we know is minus a half. However, remember there's this minus in between. Okay, remember this is still working out inside our square brackets. Okay, so a half minus minus a half is 1. So that means the answer is 1 unit squared. Okay, so again, this is pure 2 level here and substituting in. So part B, what we have to do is this. So we are now finding the volume between pi over 2 and 0. When we're doing volume, we're going to have pi on the outside, and whatever our function is, we're now going to square with respect to x. Now, step 1, before I integrate, I'm going to square this first. However, this is better for us to keep it like this, okay, because we're now dealing with a trig function. Like if we'd have left it as sine squared of 2x, do you remember when we integrated in pure 3? Now this is like a chain rule. Like this is what we're going to do. So we're ready. So to integrate this, we are going to have, now remember we're going to multiply it all by pi at the end. Okay, to integrate this, so if we forget about what's happening, right now we have a bracket squared, yeah? How do we integrate something squared? We increase the power by 1 and divide by the new power. Okay. Then, what do we also do? We need to divide by the differential of the bracket. What is sine of 2x differentiated to? Cos? No, sine does not differentiate to negative. Okay? Sine of 2x differentiates to 2 cos 2x, and we divide by the differential. Okay? Now, this is where some people now mess up, is how do we simplify this, okay? This is where we're now going to get to. Okay, so you've probably got to hear and think, right, what am I going to do now? Well, let me tell you now, this is an epic mistake. Okay? Those of you who followed along with me then, really go back to the Pure 3 videos. Okay? Because, yes, this part is correct. However, do you remember in Pure 3 we said, what aren't we allowed to do? We're not allowed to integrate trig functions, okay? So, we know that this is double angle formula. Okay, so we have to change this now. Please watch out. Now that you've seen this mistake happen in real life, are you ever going to make it again? No. Okay, so how do we, what are we going to use instead of sine of 2x? Cosine? What does sine 2x equal? Come on, guys. Yeah, the trig identity. 2 sine x cos x. But it's still what? Squared. So we've used this one, but then we come to the conundrum again, where actually what happens now is we're going to end up with 4 sine squared x cos squared x. Is this going to help us? No. Okay, this is called intelligent practice. So what we have to now do is go back and say, right, well, what are we going to do? This is why I know we don't cover trigonometry in Pure 4, but you're going to need it. Okay, you are going to need it for integration, differentiation. So what would be more beneficial is we have sine squared 2x. What could we use? What other trig function could we use that we know how to integrate? That we can, which trig identity could we use to substitute and use this now? Sine squared plus cos squared equals 1. We're still going to end up with cos squared. So that's not quite if we rearrange this, so sine squared equals 1 minus cos squared, we still end up with a cos squared. Do you know how to integrate cos squared? And square root that. Do you know? Okay, so let's say sine equals 1 minus cos squared rooted. Do you know how to integrate that? No. Okay, next. Let's think of these trig identities. Trig identities. 1 minus 2 sine squared x equals cos of 2x. Now this is better. Are we managed to now get rid of, do we have a sine squared? Yes. So now I'm going to get minus 2 sine squared x equals cos of 2x minus 1. I'm going to change this round. So sine squared x equals 1 minus cos of 2x. Now watch out for this. What do we have though? Sorry, I need to divide by 2. Okay, however, I didn't finish that part. Right, what we have here though is we have sine of 2x, right? So this is going to be a 2x, so what does that make this now? 4x. That's the bit to watch out for. Okay, so we're now going to have a half minus a half cos of 4x. Now are we at a stage where we can integrate? Are we at a stage where we can integrate? Right, these are all the traps that are going to be there for you. So those of you who, you know, are thinking I might not sit pure free because I want to guarantee 95 on this. Just letting you know, is it easy to make a mistake in these types of questions? Okay, we're going to need to memorize these rules inside and out. And we can, and we will, okay? So now, let's start integrating this. So we're going to have pi multiplied by. Are we ready? What's the integral of a half? Half x. What's the integral of minus a half cos 4x? So sine, cos, minus sine, minus cos. If we integrate minus cos, what do we get? Minus sine. So this is still going to become minus a half sine of 4x. Now we need to divide by the differential of the bracket. The differential of 4x is 4. What's minus a half divided by 4? Minus an eighth. Where did a quarter come from? Honestly. Right, guys, so now what we're going to do is we're going to substitute our limits in. Pi over 2 is 0. What you're going to love is at the end of this, once we figure it out, I'm going to tell you how you're definitely going to know if you've ever gone wrong in an exam in 2 easy steps. Okay? How do you know if you've used the wrong trig identity? I'm going to tell you. It's not even 2 easy steps, probably 1 easy step. Okay? Keep watching, like and subscribe. No, I'm joking, guys. I'm joking. I am actually going to show you how to know if you've gone wrong. Right, first, so let's carry on with this. So, pi lots of, what's the half of pi over 2? Pi over 4. Do you need a calculator? No, do it without a calculator. Come on, you've got this. Minus 1 over 8 sine lots of 4 times pi over 2 is 2 pi. This is then going to be minused by a half of 0 minus an eighth of sine of 0. Okay, I want us all to do this step by step. So, what is an eighth sine 2 pi? So this is a quarter pi. Minus a quarter pi. No. Sine of 2 pi is 0, thank you. So this is just a quarter pi, brilliant. Minus 0, and then what is sine of 0? 1. So this has become minus an eighth. So now the answer is, what is it then? What's sine of 0? 0. Oh, so this is just 0. Yeah, I'm not listening to you anymore. What, honestly, So I'm going to have, and remember this is all multiplied by pi. So my final answer is pi squared over 4. And what's the units cubed? Okay, guys, so are we ready to find out in that one simple step if we're right or not? Okay, those of you who bought the most lovely calculator. Yeah, this is what I told you. You're going to need this for pure force. Some of you might not. Right, this is what you're going to do. You're going to put into your calculator. You're going to put this into your calculator. Okay, so I'll take a picture and show you in a second. So, basically, you can see we haven't in the calculator multiplied by pi on the outside. However, if you did put shift pi, I'll show you what you're going to get in a minute. It's going to give you a decimal. So personally, I'd leave the pi out. But you can see in your calculator that when we integrate between these two, we're going to get a quarter pi, which is exactly what we had here before we multiplied by pi. Okay, so if you were to do these incorrect ones and then you substituted in and you didn't get this, you know you are incorrect. These questions, though, even if you get the right answer, you have to show you're working, okay? However, it's really nice that you can actually check if you're right or not with these values, which is what I love, and this is what makes the parametric ones and this one easier in terms of your understanding, you know? It kind of does show, so it's really good. We'll go through this together, and so everyone knows how to do this, okay? Well done. Okay, so test your understanding. 7-mark question. Now, if you notice, this is just part C. So part C is worth 7 marks. That's where we're at right now, okay? So, the finite shaded region S shown in figure 3 is bounded by the curve. The line x equals root 3, okay? So this then tells us this will be our upper limit of x. And the x-axis. The shaded region is rotated through 2 pi radians about the x-axis to form a solid of revolution. This immediately tells me we're going to be working on volume. Okay? Find the volume of the solid of revolution, giving your answer in the form, etc. And they've given us a bit of answer. Okay, so volume is worked out by, we're going to do the volume between the limits of, what is it? Root 3 and 0 of y squared with respect to x. Okay. So, now, we have parametric equations, okay? So to find this dx, we're going to have to integrate between, okay, first of all, we have y squared, we're going to have dx by d theta, then all with respect with our d theta, okay? We're going to multiply this by pi, and we need to change the limits. So this is now our new formula, okay? Our new formula. So, first of all, if x equals root 3, how do we find what theta equals? First of all, let's do our limits. We know that x equals root 3 and x equals 0 from the question. We know that x equals tan theta. So, to find theta, we're going to do inverse tan of x. Everyone happy with this? So, when x equals root 3, inverse tan, so shift tan to the root 3 is going to give me a third pi. So my root 3 limit is now a third pi. So here I'm going to have a third of pi. Okay. Now tan of 0, so shift tan of 0 is also going to give me 0. So now I have my limits and they match. Okay, so I've done my limits. Now, y squared is in fact sine theta squared times, what is dx by d theta? If I differentiate tan, what do I in fact get? I think it was in the formula sheet, in the formula book, we have like secs, don't we? Do you remember? So dx by d theta, tan differentiates to sec squared. Please make sure, so this now becomes times sec squared. Okay, now this is all respect to theta, but technically dx, okay? So this is between a third pi and 0. Okay, so now what we're going to do, before we integrate, we have to integrate. This is an integration question. However, before we integrate, we need to put this into a nice format. So, I'm going to have sine squared theta times sec squared theta. Okay? Actually, do you know what? I'm going to move this over here. Right, let's make this nice first. What's sine squared theta times sec squared theta? This is actually sine squared theta over cos squared theta. Does sine squared theta over cos squared theta give me tan squared theta? Yes or no? Tan squared theta. Okay, can we integrate tan squared theta? No. Okay. Tan squared theta, so we know we're not done yet. We can't integrate this, so we're not done yet. However, tan squared theta is in fact... okay, wait there. I can't remember. So do you remember what I do when I can't remember? So I know that sine squared plus cos squared equals 1. How do I find tan squared? I divide by cos squared, yeah? So tan squared is actually sec squared minus 1. Everyone happy with this? Okay, this is how I remember it, because I don't remember it, so I just quickly divide. Okay, so sec squared theta minus 1. Now, literally, whenever I'm doing this in the exam, I've got the formula book in my hand. Okay, literally got this in my hand. Can I integrate sec squared? I can. Okay, can I integrate minus 1? I can. I now have this in a form I can integrate. So I know that sec squared minus 1 is now what I'm going to use, you know, from the trig identity. So now I'm going to integrate a third pi, lots of pi, between 0 of, wait, what did I say? Sec squared theta minus 1 with respect to theta. Okay, so now I'm going to integrate. Here we go. Sec squared theta integrated integrates to tan theta. Okay, from the formula book. This is from the formula book.
Where did the sign go?
The sign went sine squared plus multiplied by sec squared is sine squared over cos squared. Sine squared over cos squared is tan squared. We can't integrate tan squared. We don't know how. However, we know that tan squared is also sec squared minus 1. We can integrate sec squared. It told us in the formula book. Okay. And here is the formula book. So you can see integration of sec squared is tan. Okay? So we have that there. So now we're going to have tan theta minus 1 integrated is just theta. Well done, because we are in terms of theta. We're now going to multiply this all by pi in the end. However, this is between a third pi and 0. So we're going to take this slowly. First of all, we know we have our pi on the outside. So tan of pi over 3 minus pi over 3. This is all minus by tan of 0 minus, oh, sorry, I accidentally wrote theta. 0, 0, minus 0. Okay, so first of all, we're going to break this down because some of us, when we're using our calculators and putting in the whole thing, we're going to lose marks. What is tan of pi over 3? I'm literally just going to put tan, shift pi over 3. I get root 3. Minus pi over 3. Minus, what is tan of 0? So tan of 0 is 0. So minus 0 minus 0. So that's all just cancels. So I'm now going to have root 3, pi root 3 minus pi squared over 3 when I expand this out, right? Okay, first of all, now I'm going to do 2 checks. Check number 1. It asked us to put this in the equation, p pi root 3 plus q pi squared. Okay, so what does our p equal according to this? 1. Because 1 times pi over 3 is pi over 3. What does our q equal? Minus 1 over 3. Because pi squared times what is negative pi squared over 3. So now we have this. However, what I'm going to do now is I'm going to put, this into my calculator. The one we did before we used our trig identity to make sure that our trig identity is correct. However, remember we're not going to multiply it by pi, so you have to think we should have root 3 minus pi over 3. Or if we put pi on the outside, we just press SD and see if we get it. So let's see what happens now. Okay, so I get 0.68. When I then multiply this by pi, I get 2.151. Okay, after this, I times it by pi, I get 2.151. So now what I'm going to do is I'm going to put this into the calculator, and I'm going to see what my answer is. So now, when I typed this in here, you can see I did get 2.15, which is what happened once I'd multiplied this by pi. So I know that what I've done is exactly right, and I can walk out of this exam confident that I've just guaranteed myself 7 marks. So that is 7 marks. Okay, so question 5, part A.
Yeah,
Where is the question?
on my phone.
Okay, let's see the question. So question 5, part A, says the diagram shows a sketch. We have y equals 9x to the power of 3 over 2 minus 3x to the power of 5 over 2. The region is bounded. Find the coordinates of A. Okay, now clearly from this sketch, okay, it's basic. It's basic. Here it is, we have A. This is our region R. Okay, let's go back to basics. This isn't even pure 4 stuff now. This is back to pure 1, believe it or not. Okay, we ready? Coordinates of A. What can you tell me? We know that this coordinate was that 0, 0.
Yeah.
Okay. What is this coordinate of A? What do we know straight away? Something 0.
The y coordinate is 0.
The y coordinate is 0. Perfect. So when we're going to solve this, we know automatically this is 0 lots of this.
Yeah.
Okay. 5 over 2. Okay. Now, we know this equals to 0. Okay. We have 3 over 2, 5 over 2. Guys, we can literally, let's move it over. X to the 5 over 2 equals 9x to the 3 over 2. If I divide both sides by x to the 3 over 2, I get 3x. 5 over 2 minus 3 over 2 is 2 over 2, which is 1, which equals 9. So x equals 9 divided by 3, so x equals 3. It's really simple, really. So it's not simple. So what have you done? Have you tried to factorise out? Okay, so when factorising out, you'll notice straight away, we only really factorise if it's like a quadratic, a cubic. What you've got now, it's better, if you did factorise and then realise you wouldn't know how to solve this equation, go back to basics. Okay, go back to basics. That is the best way to do it. So now we know that this is 3. And now from here, you can find the area through integrating or the volumes of revolution. Okay? Right, guys, so integration by substitution. Sometimes there is a complicated expression. So the best way to do it is to substitute. As you can see here, this is complicated, and technically we have, it looks like a product, doesn't it? X multiplied by 2x plus 5 to the power of a half. Technically it is a product, and you know, like when we've been doing reverse chain rule, this isn't going to work here, okay, because it looks like a product. Okay, so what we do is we use substitution. Now some people teach this in pure 3, however we didn't need to because we were just doing reverse chain rule, right? So this is what we do. So step 1, it will either tell us in the exam, use this substitution, and here they've clearly said, use this substitution. Or we have to figure out the substitution, which we'll come to in a second. So when it says use this substitution, whenever we look at substitution, we need to, the aim of the game now, think of this as a game. We want to get rid of all the x's and we want to have u's, okay? So step 1, we have our substitution. So u equals 2x plus 5. Is everyone happy with this one? Okay, we're going to do 2 things from this equation. Number 1, we're going to differentiate. Number 2, we're going to rearrange. Okay? So, number 1, we differentiate. If I differentiate, I get 2 du by dx equals 2x differentiates to 2. 5 differentiates to? Nothing. Okay. So step 1, differentiate. Step 2, okay, so step 1 is differentiate. We differentiate one thing. Step 2, we rearrange. Guys, you need to rearrange 2 things. You're going to rearrange this to have it in terms of dx. So I get du equals 2 dx. So dx equals du over 2. Okay, now the second rearranging is we're going to rearrange u to get x equals. So I'm going to have u minus 5 equals 2x. So what does x equal? Yeah, this equals u minus 5 over 2. Okay? So now we have a clear thing for what we have. We have our substitution. We've rearranged it to get x. We've differentiated and then rearranged the differential. Okay, everyone happy with this? Now we're going to use this to substitute in what we already have. So for example, we have the square root, the integral, it's because there's a square root coming. You see my brain's working faster than my mouth? The integral of x, what is x now? U minus 5 divided by 2. Multiplied by the square root of 2x plus 5. Now guys, do not write 2 lots of u minus 5 over 2. You're being silly now. We already said that 2x plus 5 was u. Okay? So it's the square root of u. Please don't be silly. And then, instead of writing, so x we've substituted out for u minus 5 over 2. 2x plus 5 we've substituted out for u, because we said that was the substitution. Dx we're going to substitute out for du over 2. Okay guys, now I've substituted everything back in. This is why it's called integration by substitution. Now before I integrate this, I'm going to expand, simplify, rearrange. Because the whole point of this is going to make our life easier. So are we ready? Let's zoom in and let's do this step by step. So I'm going to get u over 2 minus 5 over 2 multiplied by u to the power of a half divided by 2 with respect to u. This is what we're integrating technically, isn't it? So I've split this up, I've turned this, and I've moved this half over here. Everyone happy? Because technically it's all multiplied, isn't it? Right? Now I'm going to multiply this by everything inside the bracket. So this then equals the integral of u over 2 multiplied by u to the half over 2. U to the power of 3 over 2, because we add the powers, over 4. Guys, from this point out, this is pure 1, 2, 3, even GCSE. Okay? Then, u to the half over 2 times minus 5 over, what are we going to have? Minus 5u to the 3 over, no, sorry, to the half over 2, 4. Why would you say that? And this is with respect to you. Okay, now what type of integration problem do we have? We're going back to pure 1, aren't we? Is pure 1 integration here? Because are these integrations simple to do? Okay, so let's integrate then. Okay, so by the way, step 4 we haven't got to yet. Okay, we're still on step 3. Step 3 is continued on here. Right, so let's integrate this. So what do we do? Increase the power by 1. What does this mean? Yes, 5 over 2. Divide by the new power. So a quarter divided by 5 over 2. Is that 2/5? It's a tenth. What am I doing? Yeah.
Oh, no, it is 2/5.
It's
No, it's not.
no. What is it?
1 over 10.
A tenth. Okay, brilliant. And then increase the power by 1. 3 over 2. Divide by the new power. So at negative 15 over 8. Five over 6. What am I doing in my head? minus 5 over 6. Oh, sorry, guys.
You're scaring yourself.
Yeah, I'm scaring myself. And then what do we have? Plus C. Thank you. Yeah, oh snap. Okay, so now we've integrated this. Now the final step, we did use substitution. Okay. The original question was in x's. Do you think I now need to put it back in terms of x's? Of course I do. What did we say u equals? 2x plus 5. So therefore, the final answer is 2x plus 5 to the power of 5 over 2 all over 10 minus 5 lots of 2x plus 5 to the power of 3 over 2 all over 6 plus c. And there we have it. We have now used substitution to help us integrate. So I'm just going to use some colours. Is everyone ready for this colour coding? It's wild. Okay, x, we know that x can be written as this. So I substituted this here. We know that 2x plus 5 can be written as this. So I put that here. Okay? And we know that dx, once we did all this, can be written as du dt. So I put that here. It's literally substitution. Get your colour coding out. It couldn't be any easier. It's practically telling you what to do. Okay? This is all we've done is rearrange. So let's have a look at what happens. What to choose as a substitution is actually the hardest part of this question, because sometimes they don't give it to you. So are we ready to look at that? So how do we know what to use? Okay, guys, there is no rule for this. There is no rule. Basically, the only rule I have is this. If it's inside a square root, use this as your substitution. This now becomes a u. If it's a complicated power, use that as your substitution, okay? If we have a fraction, your substitution is more likely the denominator, okay? However, we'll go through this. So for example, for this one, what would you say a sensible substitution would be? Yes, so we would say u equals 1 plus sine of x, because it's inside the square root, right? For the next one, what would a potential substitution be? X squared, yeah. Okay, for the next one, what would a potential substitution be? Because this time we have to the power of x, but also we have a denominator of 1 plus x. Personally, 1 plus x is more complicated than x, right?
Yeah.
I always go for the more complicated one. So 1 plus x it is. The denominator of 1 plus x. 1 plus x is technically more complicated than just x. Yeah? Okay, the next one. This one's easy because what? Okay, this time to the power, what's more complicated? The denominator of 1 plus x or the actual power? The power. So it is 1 minus x over 1 plus x. So these are sensible ones. Now, the more we do this, the better we're going to get at spotting these. Okay? So we're going to do one more. Are we ready? Here we go. So in this question, they've given us the substitution. They've given us the substitution. So it says use the substitution sine x plus 1 equals this. Okay, step 1. We have u equals sine x plus 1. Okay, step 1. What's step 1? Differentiate. Du by dx sine cos minus sine minus cos. So sine differentiates to cos of x. Perfect. I now need to rearrange this to get what? Dx. Okay, because why do I rearrange? The whole point of differentiating this is so that I can get this dx substitution here. If I rearrange this now, I get dx equals du over cos of x. Perfect. Okay, now let's rearrange u. So u minus 1 equals sine of x. Okay, perfect. Now let's see if we've got everything we might need right now. Okay, here we go. So first of all, before I start doing this, I do a check. Okay, have I got dx? Yes. Du over cos x. Okay, check. Have I got 1 plus sine x? What is it? It's u. They gave it to us in the question. Have I got sine x? What is it? Brilliant. Have I got cos x? Have I got cos x? I do, du over dx. However, that means I'm going to have 2 du's, aren't I? I've already used that. So can't quite do that. What do I know that relates sine and cosine? Don't. at me. Come on.
Cos squared plus sin squared.
So I know that cos equals the square root of 1 minus sine squared
Which is u minus
x. Okay, so technically, do I have cos of x now? Cos of x is equal to the square root of 1 minus, what is sine squared x? U minus 1 squared. Okay, so now do I have what cos x equals? Okay, now what do I do? Substitute in. So I'm going to have the integral of, are we ready? Square root of 1 minus u minus 1 squared multiplied by what sine of x? U minus 1 multiplied by what is 1 plus sine? U cubed dx, which is du over cos x. Okay, now, guys, this is a real learning moment. We've just realised, actually, that we never... Has this made it more complicated? Does this look complicated? Yeah. But do you know what we realise, guys, when we get to this stage? And this is why I've done this on purpose. We never actually have to substitute this one now. Because of this cos x here, I can leave this cos x here and it's going to cancel out. Now, the whole point of this example is to show you that even though we follow this method of making sure we have everything, we actually have never needed to rearrange this, because what we would be looking at our sensible option. So it's really important that when you get to this stage and you think, oh, that looks a bit complicated, when you then write it out, you can then use your common sense to realise that cos of x is now going to cancel with cos of x. Okay? So now it's literally pure one level integration, where we now need to simplify this expression. So this is now going to be, continuing step 2, the integral of u minus 1 times u cubed. I'm just going to write this again so that we can see u minus 1 times u cubed du. Okay? What does this equal? This equals the integral of u to the power of 4 minus u cubed with respect to u. Yeah? So if I integrate this, what do I get? Increase the power by 1, 5, divide by the new power. Minus, increase the power by 1, 4, divide by the new power, plus c. Okay, does anyone remember what our u was? Sine x plus 1. So now, therefore, this equals sine x plus 1 to the power of 5 over 5 minus sine x. Oh. Ah! Sorry, guys, I don't know what, just like, it's like a pen explosion, isn't it? Sine x plus 1 to the power of 4 over 4 plus c. And there we have it. We've now used substitution, and as like I said earlier, there is no set of right rules, right? There's no set of right rules to say what you use to substitute. You just have to be a bit clever. When you are following the rules of substitution, again, be a bit clever. You already know, like, you should have spotted that this looks complicated. However, if you didn't, it's okay. Getting to this stage is fine. Then realising that these are going to cancel. The aim of the game is not to have any x's once you've substituted. If you've got any x's here, after you've done all your substitution, you've gone wrong. Okay? So it's a really good thing to know how you've gone wrong. Okay, guys, so, as you know, it never stops, does it? We can use substitution involving implicit differentiation. I know what you're thinking. It's never it. So, why don't we try and give this one a go? So, this question is different to the one we did before, because instead of saying u equals this, they've told us u squared equals this. So, it's only the first step that's different to this. if we need to differentiate this, we know that u squared equals 2x plus 5. So that means if we were to differentiate this, are you ready? What's u squared differentiated? 2u du dx, because we're differentiating u with respect to x. This is implicit. This is like when we had the y's, you remember? Then this equals 2. Okay? So, therefore, dx actually equals u du. Okay? So this is how implicit's slightly different. Then what else do we need to do? We need to rearrange. So u squared minus 5 over 2 equals x. Okay? Right, so to explain this part one more time, do you remember in the chapter when we did implicit differentiation, if we were to have 2y equals 4x, how would we differentiate this? We differentiate 2y, which becomes 2, and then because we differentiated y, what do we write? dy dx, right? Equals 4. However, in our case, we have u squared equals 2x plus 5. So this time we're going to differentiate u with respect to x. So if we're differentiating u squared, this becomes 2u du dx. We're technically treating our u as the y. Okay, this is what's happened. And then obviously 2x plus 5 differentiated 2. Now you have that, I want you to do your colouring in. Okay. So now we're going to substitute in everything we know. So, here we go. The first one is x. What is x? Yeah, u squared minus 5 over 2. So that's the first thing I'm going to put in here is u squared minus 5 over 2. Okay? Then, I have to put square root of 2x plus the square root of 2x plus 5. What is 2x plus 5? U squared. Oh my. I don't know what's happened here. Which is u squared, okay? So that's why I'm going to put u squared here, which is going to be u. However, just for the sake of the colouring in, we're not going to do that yet. Then the last one is dx. What's dx? U du. U du. Okay, so now I'm going to expand, simplify, sort my life out. So u squared minus 5 over 2. Root u is u times u du. So actually I'm now going to have u squared, right? So if I expand this as well, you should all be able to get the same answer as me. U to the power of 4 over 2 minus 5u squared over 2 with du. Okay, now we're going to integrate this as normal. Increase the power by 1. 5 divided by the new power. What does this give me? Increase the power by 1. 3. 5 over 6. Plus c. Okay, now what does u... Now this is the only bit it gets a bit tricky.
Do you like square root to make it just u equals b?
It's really easy. What we're going to do is we're going to say if u equals 2x plus 5 to the power of a half. Yes? When we substitute this in now, u to the power of 5 is actually 2x plus 5 to the power of 5 over 2 minus 5 lots of 2x plus 5 to the power of 3 over 2 over 6 plus c. There we go. Nice and simple. So, one of my really smart students said to me, Miss, what would happen if instead of differentiating... Oh, sorry, this is...
Who's that smart student?
It's not you. So, one of my smart students said to me, Miss, what happens if we square rooted this and then differentiated and carried on all the way down? You can see if you carry on all the way down, you end up with the same differential, however it's taking you longer, okay? Now sometimes the reason why, so this has given us the same thing. Sometimes though, this is not advised because when we square root this and now use it for a substitution, you're also forgetting there could be a positive or a negative of this, okay? So if they ever give you a substitution where it is u squared equals, stick with that substitution. even though we might be able to find the positive of it and it will still work, just be mindful of this, okay? Very good question from a very gifted student. Okay, test your understanding question. This is a 5-mark question and it gives you the substitution. I know what you're thinking. You miss trig that much. There is a bit of a double angle here, guys. Don't you worry. Okay, I'm looking out for you. Give it a go. Okay, so first step. We know that u equals 1 plus cos of x. So we're going to do two things. We're going to differentiate. Du dx equals negative sine of x. So that means dx equals negative du over sine x. Now remember that example we just went for. If there's a sine x here, guys, is it okay to then have a sine x in the formula? You tell you what, see? I even did it especially for you. Didn't see it coming. And then we need to rearrange. So u minus 1 equals cos of x. Now, even though it's told us hint, we're going to pretend we didn't see that, and we're going to work through everything we know. So, do we have 1 plus cos x? Yeah, that's u. Do we have dx? It's minus u over sine x. So that tells us straight away that we can have a sine x in our answer, and that would then mean it can cancel. Okay, I have sine of 2x, that's not the same, so I do not have that yet. However, I do know that 2 sine 2x, okay, does that equal 4 sine x cos x?
Yeah.
Perfect. Have I got sine x? Yes, that's going to cancel with this. Have I got cos x?
Yeah.
Yes, that is in fact u minus 1. Okay, so now I've coloured everything in. I know what's happening with my life. I'm going to go for it. Okay, so 2 sine x, I'm going to substitute as 4 sine x, and instead of writing cos x, what am I going to write? U minus 1. All over 1 plus cos x is u, multiplied by negative du sine x. Okay? So now, what is this going to equal? First of all, I've got a negative times a positive. I'm going to bring the negative to the front. I have 4. Now, the sine x's are going to cancel. So technically, I have 4 u minus 1 all over u with respect to u. Okay? Now I can do this one step further. We're going to have the integral of, I'm going to have negative. Actually, guys, do you know what? I'm just going to bring this negative outside here for a moment. Okay? You want me to do it the other way? Sorry, this has confused some people. This is bracket, bracket. There we go, guys. Is that making life easier? Okay. So now we're going to get 4u over u minus 4 over u du. Okay? So this is going to equal minus, and then 4u over u is just 4 minus 4u to the negative 1. Now, you're all going to want to do this, so I'm going to leave it like this. However, we should spot that when we integrate something over x, we know it's going to be a ln. However, let's just pretend that some of you forgot that. We're now going to equal minus. Okay, so integration of 4. Increase the power by 4x. U. Thank you. Now with this one, if I increase the power by 1, what do I get? 0. Alarm bells should be ringing. This is not going to be 0. This is a ln. So what do I get? Minus 4 ln of u. You absolute fool.
I didn't do 4. I did limit.
Right, which equals plus c. Okay, so now I can put the negatives back in. Are we ready? So I actually get 4 ln of u minus 4u plus c. Okay, because I've just multiplied that negative out. What was u again? 1 plus cos x. So I'm going to get 4 ln 1 plus cos x minus 4 lots of 1 plus cos x plus c. There we go. Technically, I don't know why I put that in a modulus. Sorry, I just got carried away. Technically, you could write minus 4 cos x, yeah? Now, just to be very clear, even though I showed you that example earlier of the sin x over the sin x and made a big song and dance about it, you still miss it. Okay, I don't know why, it happens every time. People do miss this. Please just remember that you might miss this, and then you know you're not going to miss it. Okay, well done. That was 5-mark question, and that was part C of the integration questions. Okay, integration by parts. It's the integration if we spot a product. Okay, so you know we have the product rule for differentiation, v du plus u dv. There is in theory an integration rule. Now, there is a little bit of a proof. It's not needed for the exam. However, I'm going to show you this when we look at differential equations because it fits in nicely with that, which is our next one. So, yeah, I'll come back to this, but on the next part of the topic. So, you know how to spot a product. Everyone's happy? Yeah? Okay, we're going to look at how we do this then. So, here we go. So, let's have a look at x cos x, okay? So, here we go. If we have to integrate x cos x with respect to x, okay? It's nice and easy. First of all, we spot there is a product. Now, there's a formula for this. However, I have no idea what it is. I have a magic square for you, okay? So, yeah, I'm going to show you a magic square. So this is how it works. You call one v, you call one u. Okay, everyone's happy with this. So, however you do this, there is a trick. For this one, it doesn't matter either way what we do because we could integrate and differentiate cos quite nicely. And I'm going to show you what it means. So I'm just going to show you this rule and then we're going to discuss, you know, like when we did substitution and which one do we use for u. It will be like that for this one. Okay, so let's say we'll call this one v, we call this one u. Okay, so what we have is that we have a magic square. Here is my magic square. Now, I'm going to explain how to do it. We're going to look at the y's and everything in a moment. I'm just going to show you this little nice trick that I remembered from my maths teacher, who was an absolute legend. Right, so either way you put this, for this particular question, it doesn't matter. However, what we're going to do is we're going to put v here. So, we've decided which one's going to be our v in u. So, our x goes here. Okay? This is our v. And then, if we go down, it's our dv. We're going to explain that in a second. Right, now the next one is our u. However, I've just labelled one as v, one as u, but technically it's not my u yet. This is now my du. So this goes here. Okay, and this becomes my u. So, step one is filling in this box. So, step one, you always have to make sure they are in the opposite sides. You have to start your box this way. One of them needs to be here, one of them needs to be here. Is everyone happy with that? We're going to discuss which one is better placed where after. Right now, this is step one. Okay. The next stage is, this box is really simple, how the mechanic of the box works. If our x is here, to then fill in this side, we differentiate. So what's the differential of x? 1. So there we go, we differentiate that one. Now, as you know, on the other side, we filled in what the differential is. So if we've got to fill in the top box, how would we then get to that, do you think? We integrate. Okay? Now, the integral of cos is, in fact, sine. Okay, remember? So sine cos minus cos. We're going to integrate. We're going to get sine of x. Okay? Now, everyone happy with the first stage of this? Really simple. Now, the next stage is my favourite. Statistically, what do you think people's favourite number is in the world between 1 and 10? 7, thank you. Statistically, number 7 is people's lucky number 7. I want you to remember that because this is now what we're going to use. So, does anyone know how I draw a 7? Yeah, so I start here, I go across. Everyone happy? Now, so I've started, I've gone across. That means my first answer I multiply this is x sine x. Is everyone happy with that? That's my first bit. I've gone across x sine x. Now the second part is, you remember when we, this has to be a minus now. It has to be a minus. Okay? Then after the minus, you always write the integration sign again. Always. Okay? And then, does anyone remember how we finished drawing a 7? We go across, don't we? Okay? If you think a 7 does not look just like that, it's always a bit diagonalized, isn't it?
Yeah.
Okay? So then we go across. So then what's sine of x times 1? Minus the integral of sine x with respect to x. So now what we have is, we carry on with this, so x sine x minus, what is the integral of sine of x? If we integrate sine of x, minus cos of x. We're not integrating with limits, so what's our most favourite thing that we now have to write? Plus c, because of our constants of integration. Therefore, x sine x, what's minus times a minus? Plus cos of x plus c. That is what the integration equals, and this is how we've solved it. Okay? So I want you to just have a quick moment looking at this before we ask any questions, and then we're going to look at actually when is it a sensible option to choose which one do we know goes here, which one do we know will go here. This is what we're going to look at as we go more in depth into examples. Now, it might seem like this was really complicated because it's taken 6 minutes to explain. However, you get this done really quickly once you know where everything goes. There is obviously a formula, and if you want to use a formula, you can use the formula. This way it's just, you'll find that with this way, you're already setting everything up like you would do if you were using the formula. Okay? Just for those who are curious, the formula is uv minus the integral of v du dx. Okay? So which is just what we've got here. However, what you don't realise is when you have this, you're literally saying to integrate by parts that one of them's already differentiated. So just like we did, I think their v and u might be the wrong way round for ours. You know, we did this times this minus the integral of those two. So they've just put their u and v the wrong way round. That's okay. Okay, so we've just done this example. So I'm going to mix it up. Let's change this now. Let's have a new question. Let's say you're going to integrate between x and sine of x with respect to x, okay? Just so that you can give this a go. We'll go through this answer as well. So I want you to do the same thing that we've just done, but with x and sine of x. Off we go. Right, so let's quickly do this then. So we've chosen to have x here, sine x here. So this is our first step, is that we write the opposites, yeah? And again, I said to you in a minute, we're going to find out which way we write where and why, yeah? This was just practicing these steps. So after we do this step, what's my second step? I'm going to differentiate x, because I'm going down. What do I get? What's x differentiated? 1. And then my second step, I'm going to integrate sine, which is minus cos x. Okay, so now what's my next step?
7.
The magic number 7. So x times minus cos is minus x cos x. Now what's the next step I have to write? Minus the integral. Even if you're doing this rule, we still have to follow. It's the same rule. I've just done it in a nicer way. I've tried to do it so that you can remember it a bit more with the 7. Okay, it's still the same formula, written differently. Then I'm going to minus the integral of minus cos of x. Now, fun fact, if you really wanted to, we can write this out again, and you can factor out a negative from here and put a plus here. You can do that. Either way, we're going to get the same answer at the end. Just be careful when you're doing this and you make sure that what you're doing is right for that question. For this one, we can factor out a negative, right? So then we're going to have minus x cos x plus, what's the integral of cos of x? Sine of x with respect to x plus c. Well done. So even if we'd have done this one, the integration of minus cos is minus sine, and then we would have had minus times minus, which then would give us a plus. So there's the answer. Okay, so in terms of the steps, how do we feel about this now? Feeling good? Yeah? So now what we're going to do is for the previous example, what did we have again? We had x cos x with respect to x, right? And I said to you we had to put x here and we had to put cosec here. Okay, I want you to try it the other way. See what happens for me. So this time I want you to put cos x here and I want you to put x here. Okay? Can we all give that a go? Okay, so what will happen is you would have done it. You would have, remember, from cos of x we differentiate, we get minus sine of x. From x we integrate, we get half x squared. So our magic number 7, we're going to get cos x times a half x, which is here. And then a half x squared times minus sine x, which is here. What we now notice is we have another product. The whole point of doing this was to integrate the product, and we've now done it. So, as a rule of thumb, are you ready for this, okay? It's common sense that whenever you're choosing your box, you want it so that whatever these two are, they do not multiply to give you a product of two functions. Okay? Because if these two multiply to give you a product of two functions, then you're going to be integrating another function again. Now, if you try the box both ways, and that is the only way, sometimes we do have to do it twice. It's rare, but we do, and we'll come to that in a second. However, ideally, you want these to be either one function or a constant. If these are two functions, then that's pretty much how you know. Okay, so that's how best to decide which one you differentiate. I always like to differentiate anything that's going to give me a constant here, because that's always a nice number. So if I had 2x, I'd put 2x here, differentiate that, okay, to get 2. That kind of thing. So we're going to pick up on how to do it. However, you've seen by this that by doing it the other way, can you see it's become a lot more complicated? You're just going to make life easy for yourselves. It's more about common sense again. So here we go. Okay, so we have x squared ln x. So step 1, we're going to do this example together. And before I really get into it, we're just going to have a quick discussion. So please don't write down what I'm about to do. Okay? So let's think about this in terms of our two boxes. Okay? And which one we're going to put where? There are two options. I can have x squared here and ln of x here. Or I can have ln of x here and x squared here, can't I? Now, I wouldn't suggest doing this for every question and then working this part out, because you should be able to do this in your head. What does x squared differentiate to? So we are going to work this all out. However, you're going to then notice patterns. What does x squared differentiate to? 2x. Does anyone know what ln of x integrates to? No one knows? No. Okay. Guys, this will be in the formula book. But however, can we already see that we're not really sure on this? Okay? So wait there. What does ln of x? 1 over x. So we know that one. And what does x squared integrate to? X cubed over 3 divided by 3. Now, what we're going to notice straight away is, first of all, no one in the room even knows how to do this part yet. 1 to the power of x. So, just for those of you who are curious, what is it, ln?
It's like x ln x minus x plus
x ln x minus x plus c. Okay, we'll get to that in another day. Okay. However, what I'm trying to say is already we know that this one is not the right one for us. And then sensibly thinking, if we do x cubed over 3 multiplied by 1 over x, we get one function which contains x, which we could then integrate. Okay, so this is how we now use it smart. So I would always do this in my head. If you think, can I integrate ln of x? No. Okay, basically, guys, this is a flat-out rule. Ln x always goes here, by the way. However, what I want you to do is still make sensible choices and come up with this yourself. You'll find that becomes a rule in your head. So, here we go. So now, is everyone happy we filled out the box? We've done it sensibly. We know this is the right choice. So, magic number 7 then. Ln x times x cubed over 3 is going to be x cubed over 3 ln of x. What's next? Minus the integral of x cubed over 3 times 1 over x with respect to x. Now, I would simplify this straight away in my head. However, sometimes we do make mistakes. It is easy to do. I would suggest writing this down in the exam. Some of these integration by parts are 7-mark questions. Okay? So then.
This is not x cubed over 3?
Yeah, I don't know why the 3 didn't come through, thank you. So, are we ready? So we're going to have x cubed over 3 ln of x minus the integral of x cubed over 3 multiplied by 1 over x is x squared over 3 with respect to x. I can now do this, so I'm going to get x cubed over 3 ln of x minus, okay, x squared over 3 integrated is x cubed over 9 plus c. Absolutely fantastic. And there we go. We've now done necessarily what could be a potentially hard question in a few easy steps. Okay? Okay, guys, so I'm going to let you guys do this. By the way, IBP twice, you are going to have to use integration by parts twice. Because no matter which way you do it on the first one, you're going to end up with another product. It's just the nature of it, because when you differentiate or integrate e to the x, it's still e to the x. Okay? So you're going to have to do this twice. I want you to give it a go. Just know that you're going to have to do this one twice. Okay, so I'm going to start this slowly. Tell me when to stop if you want me to slow down. Okay, so we know we're going to do this twice. So, first of all, I pick my magic 7. So, x squared and e to the power of x. Now, you're probably thinking, why haven't I done it the other way? I will show you why in a moment. This will be the right way. Oh, actually, no, let's quickly do the other way as well. E to the x, x squared. Okay? So, x squared differentiates to 2x. E to the x integrates to e to the x. E to the x differentiates to e to the x. X squared integrates to x cubed over 3. Okay, which one looks more complicated? The right-hand side. Okay, so I'm going to stay clear of that. I also know that regardless of whichever way I choose, I'm still going to have a product because I've still got 2 different functions of x. However, which product is going to be easier to integrate? It's this product, okay? So, like they say in Japan, no. I'm not going to do that. So, are we ready? I'm going to go with the first one I've chosen. So, magic number 7, x squared times ex is x squared times ex minus the integral of ex 2x. So 2x times e to the x. Now, I know what you're thinking. I've got another product. Now, FYI, the biggest mistakes that happen are the negatives. Okay? You can see why this is going to happen. So, we're going to have x squared e to the x minus. Please try and use a square bracket, just because it would be nice to do. Now, we're going to minus this. Now, we already have another product, so I'm going to do another square. So we have 2x. I'm going to put here because 2x is going to differentiate to 2. And what did I say? If we ever differentiate to a constant, that's probably the best thing that we're trying to get to, yeah? So if 2x goes there, e to the x goes here, e to the x integrates to e to the x. So we're going to have another magic number 7. 2x times e to the x is in fact 2x e to the x minus the integral of 2 times e to the x, which is 2e to the x with respect to x in this nice little thing. Okay, so I'm going to carry on. So x squared e to the x minus, now, so I'm just going to sort out inside the square bracket first, yeah? 2x e to the x minus 2e to the x integrated is just 2e to the x plus c. Perfect. Now I'm going to expand this out. So x squared e to the x minus 2x e to the x plus 2e to the x. And then even though like we're doing negative times a plus for the c, we always still put plus c because we're adding a constant. The constant could be negative. However, the whole point is that we'll add a constant of integration. Yeah? So please make sure you still write plus c. So here's our final answer. Now you can see from here that most of the mistakes people make on this question are through the negatives. Okay, this negative bit here. Another mistake that we've just highlighted, okay, and 2 people have just done this in the class. Guys, if we're going up, we integrate. Some people have been going from here to here and differentiating. Okay? Right, so I want you to now test your understanding with this type of question. Okay, you've got this. Take it slow. Remember, at the minute, it doesn't matter about time. It's about choosing sensible options and figuring why is one more sensible than the other. Okay, having those conversations. Okay, so we're going to integrate between sine x squared sine x. So what did you put? X squared here? Sine x, because this is like a sensible option. So we differentiate to 2x. We integrate to minus cos of x. Okay, so now we're going to have x squared, so minus x squared cos of x multiplied by, so minus the integral of minus 2x cos x, right? However, some of you might want to take this minus out now.
Yeah, that's what we did.
Okay, you now have to remember that this integration, we're still then going to get like another minus technically. So, because this is another product, might be best to just leave this if that's what's then messing up your minus and plus signs. Okay? So this would be a case where it's better to just leave this, don't factor the minus out because we're going to go wrong somewhere. Earlier when we said factor the minus out, it was literally because it was like one function that you're integrating. Don't factor the minus out of a product, or if you know that you're going to have to integrate by parts again. Okay, so I know earlier we had a sneak peek into integrating ln of x because some people needed to know the answer, okay? However, what's really exciting is that I'm actually going to show you how to integrate ln of x, okay? So, what have we been doing this morning? We've been integrating by parts. Okay, we've been using our magic number 7 method, which is the same method, it's just laid out differently. You know, just like, it's like silly cow, isn't it? Yeah? It's just an easy way for us to remember things. So that's all it is. It's the same method as a formula, just an easy way to remember it. So what we're going to do is we're going to integrate ln x. So first of all, you're probably thinking, well, hold on a minute. The method we're using is for what? Integration by parts is for? Products. Absolutely. Okay, it's for products. Ln of x, is this a product? Yes or no?
Yes.
No.
It is a product of what? So those of you saying, no, it's not, no. It is a product of 1 times ln of x. Okay, technically speaking, ln of x can also be represented as ln of x all multiplied by 1. I mean, technically, couldn't it?
Yeah.
I know what you're thinking. You can't just start making stuff up like this. Well, guess what? We can. It's maths.
I've always seen that one.
Okay? So, what we're going to do to help us, we know that we want to find out what ln of x integrates to. Okay? So, there's no point us putting ln of x here, is there? Oh, obviously not. Because what would we have to do if we put it here? We then have to integrate it. No, the whole point is we want to integrate this. So we're going to use ln of x and 1. Okay, so once we fill in the box, what happens now? Ln of x, we differentiate, and this becomes 1 over x. Okay, 1, what happens? We integrate it, it becomes x. Okay, so now our magic number 7, x ln of x minus the integral of, what's x over x? 1 with respect to x. So what we then have is x ln of x minus, when we integrate 1, what do we get? X plus c. So there we go. So earlier when you were like, Googled it, and you were like, oh, it's x, like, you know, ln x minus x. This is how we prove it. Okay? This is what the magic of integration is sometimes, you know, you realise why these things come about. Now, moving on. So then, the next example we're going to look at is we're going to look at definite integrals. So now we're going to find the integral between 2 and 1 of ln of x. So this is just something that you should remember. You should always remember that ln of x we can integrate by parts. Because it's not going to be in the formula sheet. I don't know. It could be. It might say show that. However, we've just integrated and we've got the answer. So we know that the integral between 2 and 1 of ln of x with respect to x is also between 2 and 1 of x ln x minus x. Okay, so we've just integrated up there. Everyone knows how to substitute these values in. Okay, this is back to pure 2. Okay, we've been doing this for years. So I'm going to get 2 ln 2 minus 2 minus, and then I'm going to get 1 ln 1. What is ln of 1? Minus 1. I know that's going to cancel to get 0, so I'm going to get 2 ln 2 minus 2 minus 1 is plus 1. So that means I get 2 ln 2 minus 1. Okay? So, nice and simple. Brilliant. Okay, so test your understanding. So you've done this earlier, haven't you? We did x and sine x in a previous example. What did we get then? We integrated x and sine x in a previous example.
We got minus x cos x.
Wait there. So we're going to do this between pi over 2 and 0 of minus x cos x plus sine of x. Okay, this is literally just substituted in. Do you know, let's not even waste time on this. We've done it. Here is the answer for anyone who wanted to see it. Okay, we should have got 1. Double check. I know some of us were a bit confused with our minuses. Yeah? Let's make sure that we get that done. Okay, so this one is an unusual one. Okay, so this is one final unusual one. I love this one. It's my favourite one. Okay, so I'm going to give you 3 minutes to get the answer. Off you go. Okay, so, right, you might dislike me when we get to how this works. But this is where the abstract mathematics comes in. Okay, in terms of not abstract mathematics, but the thinking of where this is going. So we're going to take this slow and let's see where we get to, and then you're going to see how to think outside the box. Okay, here we go. So we know that the integral of e to the x sine of x with respect to x equals. Okay, we know that this equals. So let's just get our little box going. Okay, doesn't matter which way we do this. Does it matter really? No. Okay, so e to the x and sine to the x. Right, so what we're going to notice with this is that e to the x, I'm just going to do this here. E to the x, what does it differentiate to? Yeah. And what does it integrate to? Okay, so this one's like literally, we're going up, down, it's like a circle, yeah? Never ending. And then when we have sine and cos minus cos, what does sine like differentiate to? Cos, like if we keep differentiating, we end up where we started, right?
Yeah.
And then technically if we integrate, what happens? We can end up where we started after, 4 cycles, yeah? So we're going to already, by looking at this, know we're going to be caught in a cycle. Okay, logically speaking, you know it, you've just tried it. However, this is why you've been caught in a cycle. So is everyone happy with why you've been caught in a cycle?
Yeah.
Perfect. So let's get into the cycle then. So e to the x, sine to the x integrates to? Minus cos x. Brilliant. So this equals minus e to the x cos x minus the integral of minus e to the x cos x. Okay? So what does this then equal? Minus e to the x cos x minus, okay, so now we're going to have another one, right? So we've got minus e to the x and we've got cos of x, okay? So minus e to the x, what does that differentiate to? Minus e to the x. What does cos integrate to? Sine of x. Okay, so this equals, now remember we've got to put this up here, so we're going to have minus e to the x sine x, yeah? Minus the integral of minus e to the x sine x with respect to x. Okay? Happy with this?
Yeah.
Right, because we did this times this, brilliant. So now I'm just going to, before we move any further, expand, simplify, sort out all these negatives. So this equals minus e to the x cos of x plus e to the x sine of x minus minus becomes a plus the integral of minus e to the x sine of x with respect to x. So is everyone happy I've simplified this? Now, earlier we discussed not taking this minus out because it overcomplicates things. However, what was the original equation? What was the original equation, guys? It was e to the x sine x, right? So if I was to take this minus out here, if I factor out a minus, I get minus e to the x cos x plus e to the x sine of x minus the integral of e to the x sine x with respect to x. And I mean, don't forget, there will be a plus c somewhere, won't there? Okay. So is everyone happy that the integral of e to the x sine x with respect to x equals this?
Yeah.
Do you see what I'm going to do? What am I going to do?
You're going to divide by that.
I'm not going to divide by it.
Add.
I'm going to add the integral of e to the x sine x to both sides. So is everyone happy? I now get 2 lots of e to the x sine x with respect to x equals minus e to the x cos of x plus e to the x sine of x. Okay, and then we are going to have a plus c, right? And then how do I just get that integration on its own? I'm going to divide everything by 2. No, you're thinking, Miss has lost the plot. Minus a half e to the x cos x plus a half e to the x sine x. Am I going to write plus c over 2? Yes. No. I'm just going to write plus c. We don't know what our constant of integration is, okay? However, this is how we would do it, okay? This is it. We've done it. We've now got rid of the loop, okay? So, believe it or not, this came in an exam once. This was in an exam question, and this is why Dr. Frost puts it now in his slides, okay? Because it caught an awful lot of students and teachers out. Some teachers couldn't spot it when they were actually doing it, and they sent an email in saying, it's wrong, it's not wrong, okay? So, I would just be cautious if you're ever in a loop. You know that if you're ever going to have an e to the x and you're going to have a trig function, you're going to be in a loop. So we have to think outside the box, okay? Okay, so just to confirm, so everyone's aware, so what I did was I added this integral e to the x sine x with respect to x to both sides, and that's how we ended up with 2 lots. Remember the powers of the equal sign as it balances things out. So, moving on, we're going to look at now how we're going to be integrating with partial fractions. Now, we use integration by parts for a product rule. However, there isn't a quotient rule as such. So, ideally, what we need to do is either manipulate this into a product or into something else that we can, in fact, integrate. So, using partial fractions, this goes back to chapter 1. So, first of all, what we need to do is use partial fractions to rewrite this. Now, straight away, I know that 2 over x squared minus 1 can be rewritten as 2 over x plus 1, x minus 1. Okay? So, partial fractions then say that this is the same as writing a over x plus 1 plus b over x minus 1. Now, I didn't teach you guys this chapter, did I? So this is going to be interesting to see how you do it and how I do it. Okay, guys, do you like to equate coefficients or use substitution? Ooh, 2 different people. Okay. Right then. So let's see what we can do. Okay, so everyone's happy. We're then going to have 2 is equivalent to a lots of x minus 1 plus b lots of x plus 1, okay? If you're not sure how I got to this stage, you need to go back, okay? Now, what do we do? Let's say, so you're going to use substitution, so you're going to let x equal 1? If x equals 1, okay, so if we're substituting x equals 1, we're going to get 2 equals b lots of 1 plus 1. So 2 equals 2b, so b equals 1. And then when x equals negative 1, we're going to get 2 equals a lots of minus 1 plus 0. So 2 equals negative 2a, so a equals negative 1. Okay, so what we now have is the integral of negative 1 over x plus 1 plus 1 over x minus 1 with respect to x. Okay, so now we've used partial fractions to help us manipulate this expression, okay? Because earlier it was a bit complicated with squared as the denominator. Okay, so guys, do we know how to integrate 1 over something? What is it? Ln. Okay? So we're going to have minus ln of the modulus of x plus 1. Now, we would technically divide by the differential of the bracket, but we know that the differential of x is 1. So we're not doing that, but that process is happening in my head. Plus ln of x minus 1 plus c. Now, using log laws, can anyone see how I could simplify this expression? This becomes ln of x minus 1 divided by x plus 1 plus c. And then we have it. We've used partial fractions to integrate this. 2 more examples here. I'm going to give you a head start. Off you go. Okay, so for the first one, let's do partial fractions. So we're going to have x minus 5 equals a lots of x minus 2 plus b lots of x plus 1. Now we can use substitution. Let's do x equals 2. 2 minus 5 is in fact minus 3. This equals b lots of 2 plus 1. So b equals negative 1. Then if we substitute in x equals negative 1, we're going to get minus 1 minus 5 is minus 6 equals a lots of minus 1 minus 2. So then we're going to get a equals 2. So now I'm going to find the integral of 2 over x plus 1 plus, no, minus 1 over x minus 2 with respect to x. Okay, this looks better for us to integrate. So, when we integrate 2 over x plus 1, what do we get? Two ln x plus 1 minus ln x minus 2 plus c. Using log laws? No. Yes. We have to do indices first. So what you've done is completely incorrect. You cannot now do 2 ln of x plus 1 over x minus 2. This is incorrect. Wrong, like they say in Japan. Okay? So this becomes ln of x plus 1 squared minus ln of x minus 2 plus c. Now we can divide. Ln of x plus 1 squared over x minus 2. Remember, it's a modulus of this, yeah? Plus c. Right then, so the second question. Now, remember, we're going to have a repeated root in this. Technically, this is going to give us a over 2x plus 1 plus b over x minus 2 plus c over x minus 2 all squared. Okay? So then, we know that 8x squared minus 19x plus 1 is going to equal a lots of x minus 2 squared plus b lots of 2x plus 1 x minus 2 plus c lots of 2x plus 1. Okay? Now, in this one, you've got to think what would probably be the best course of action to compare coefficients or to substitute. You know that if we substitute in positive 2, what's going to happen is we're only going to have a value for c. So we might have to do a bit of a mix. Is that okay? Absolutely. So let's start off with the easy thing. Substituting 2. So 4 times 2 is 32 minus 38 plus 1. Have I done that right? Anyone? You think so? What's minus 6 plus 1? 5? Did we get 5? And then we're going to get 0, 0, and then C lots of 2 lots of 2 plus 1 minus 5 exactly equals 5C. So C equals -1. Okay, perfect. So now we have C. Now let's have a look at how we're going to get x squared. So x squared is going to be, we're going to have ax squared here, aren't we? Okay, so guys, when I expand this, I'm not expanding the whole thing, I'm expanding little things. So I know that 8x squared is equivalent to ax squared. And then when else am I going to get a b? When else am I going to get an x squared? With b, I'm just going to have 2bx squared, aren't I? Plus 2bx squared. So now I know that 8 equals a plus 2b. I'm not expanding the whole thing. There's no need for me to expand the whole thing, right? If you expand the whole thing, you're just being really silly. So then, if I'm doing simultaneous equations, I'm going to need another simultaneous equations with a and b in. So minus 19 is the next one. Actually, I'm going to use a completely different color. Oh my. Wait there. There we go. Minus 19 x. Okay, now let's think about this logically. When else am I going to get x? Is everyone happy that x minus 2 squared, this is going to give me minus 4ax. I don't have to expand that out. You know, I'm expanding it as I go. I need to make my life easier. So minus 4ax, okay? Then I know that when I expand this, in terms of my x's, what am I going to get? I'm going to get 2x minus 2, which is minus 4x, and then 1 times x, so this is minus 3x. So I'm going to have minus 3bx. If you want to expand this long ways to see if this is correct, you can. Can you see how I'm only multiplying? I know that I just need to multiply 2x times minus 2 and 1 times x, and then that's my coefficient of x for that one. Then lastly, I'm going to get c times 2x. So plus 2cx, okay? Now remember that 2cx is going to be, so I'm going to have minus 19 equals minus 4a minus 3b, and then cx, we already know that c is minus 1, so this is going to be minus 2. So this is technically minus 17 equals minus 4a minus 3b. So I now have this equation and this equation, which I'm going to solve simultaneously. Now, I'm just going to, when I do simultaneous equations now, I'm going to get a equals 8 minus 2b. I'm just going to substitute this in. So I'm going to have minus 17 equals minus 4 lots of 8 minus 2b minus 3b. So minus 17 equals minus 32 plus 8b minus 3b. 17, 22. What's minus 17 plus 32? My head's gone blank. 15 equals 5b. So b equals 3, okay? Therefore, 8 equals a plus 6, so a equals 2. So now, I haven't even gone to integrating yet. As you can see, your partial fractions question is not going to be partial fractions. It will always be partial fractions within integration, okay? So now we can integrate. So what is my a? So 2 over 2x plus 1 plus 3 over x minus 2 minus 1 over x minus 2 with respect to x. So now it's simple integration. So if that first part of the equation is what's confusing you, you need to go back to that chapter. Okay? So are we ready to integrate this? Oh, I forgot to write the squared there, sorry. Are we ready to integrate this? Now, please be mindful. I know some of you are going to make some really silly mistakes here. Okay. Wait there. Right. Of course, there are other ways. You can substitute in. You can still substitute in minus -1/2. Okay. However, everyone needs to be happy that this way is also acceptable. However you do it, it's completely fine as long as you're getting the same answer. That's why there's more than one way. It's beautiful. Right, let's get to the matter at hand. Are we ready to see how many people make this classic mistake? Okay, guys, how do we integrate 2 over 2x plus 1? 2 ln modulus of 2x plus 1 divided by 2, because we divide by the differential of the bracket. Okay, so wait there, that's not only the biggest mistake people make either. Right? Next up, how do we do the next one? We're going to get plus 3 ln of x minus 2. Brilliant. Okay, and then the next one? Minus. Who said ln? Guys, we only have a ln. People just get carried away. Remember, this is only if it's to the power of 1. Remember, this in itself can be written as minus x to the minus 2 to the power of negative 2. Increase the power by 1. What do we get? Minus 1. Divide by the new power becomes plus. Hands up, who's a fool and put a ln there? That, right. Absolute fools. Absolute fools, okay? You're all sat there looking at me like, yeah, I've done the question. Please, please, please. This is one of the biggest mistakes that people make. Whoops. Okay, so now let's tidy this up, shall we? So we're going to get ln of 2x plus 1 plus ln of x minus 2 all cubed plus 1 over x minus 2 plus c. Okay, so this is now ln of 2x plus 1 all over, no, ln of 2x plus 1 multiplied by x minus 2 cubed plus 1 over x minus 2 plus c. There we have it. Please don't get caught out by that. Okay, so here we have an exam question, and what you'll notice is this exam question is worth 10 marks. Okay, so on that previous one, you probably thought, wow, that took a while, miss. That could be a 10-mark question. This is a 10-mark question right now that you can do, and it's actually fairly simple. This one's even simpler than the one that we've just done. Off you go. 10 marks. I'll give you a maximum of 10 minutes. Okay, so let's have a look at the answers, and then we'll discuss if anyone has any questions. Okay, so here is the mark scheme. So you should have got A is 4, B is minus 3, and C is 1. You then should have got 4 over 2 ln of 2x plus 1 minus 3 ln x plus 1 plus ln of x plus 3 plus c. Now, just to simplify this, because I know some of you would have done that, this is going to give me ln of 2x plus 1 squared divided by x plus 1 cubed times x plus 3 plus c. So also, if you've done this, this is also completely correct, okay? Then, the last part, now this is where people lose some marks sometimes. You need to substitute in the values of 2 and 0 and put this in. However, should be an exact form, we should have got ln of 125 over 81. Perfect. Okay? Amazing. Right then, let's move on. Now, I know we discussed this right at the beginning of the chapter. Do we remember top-heavy fractions? When is an algebraic fraction top-heavy? When the numerator, the highest power of x, is equal to the highest power of x in the denominator, and when the numerator, highest power of x, is greater than. Okay? So here we can clearly see this is top-heavy. How do we deal with top-heavy fractions first? I'm a silly Billy. What's I'm a silly Billy? Long division. I'm a silly Billy. Okay, are we ready? So what are we going to do? We're going to multiply. How am I going to divide? So how do we divide this? X plus 1 into, right, so are we ready? So I stands for into. How many x's go into x squared? X. And remember we're the plus 0x plus 0. Now we multiply. X times x is x squared. X times 1 is x. After that, what do we do? Subtract. X squared minus x squared is 0. 0 minus x is minus x. And then bring down 0. Okay, so x multiplied by what is minus x? Minus 1. Now, minus 1 times x is minus x. Minus 1 times 1? Minus 1. So that's 0. Remainder, what's 0 minus minus 1? 1. Okay, my remainder is 1. Please do not write minus 1. Okay, so that means that x squared plus x plus 1 can also be written as what? X minus 1 plus 1 over x plus 1. Okay, because we have our quotient, remainder, yeah? So now what we've done is essentially, this is what we've done. Is this fraction top heavy? 7 over 4. Is this fraction top heavy? Is this top heavy? Yes. Technically, what is this? This is 1 whole 1, remainder 3 over 4. So basically what we've done is we've turned this fraction into x minus 1 is like our whole 1, remainder 1. Yeah? That's what's happened here. So now once we've done that, now we can say this is the same as the integral of x minus 1 plus 1 over x plus 1 with respect to x. And now we've manipulated this expression, we can now integrate this expression. Okay, what's the integral of x? X increase the power by 1 divided by the new power. What's the integral of negative 1? Minus x. What's the integral of 1 over x plus 1? Plus ln of x plus 1. And what's the last thing? Plus c. There we go, nice and simple. So you can see the integration part of it is not difficult. Manipulating the expression to be able to integrate it is where the skill is. Okay? Oops, don't know what happened there. So, here we go. You have 2 questions to do. A few minutes. You've got this. Okay, so for the test you're understanding, we can see this is top heavy. We're going to do some division. X minus 1 into x. So what we're going to get into 1. Multiply x minus 1. Take it away, 0 plus 1. Okay, so technically this is the same as the integral of 1 plus 1 over x minus 1 with respect to x. Integrate 1 is going to give us x plus ln of the modulus of x minus 1 plus c. Okay, brilliant. For the second one, we're going to divide again. So we're going to have x plus 1 into, now remember when we divide it's x cubed plus 0x squared plus 0x plus 2. Do we remember that? So multiply x into x cubed is x squared. Multiply, so we're going to get x cubed plus x squared. Take away 0. 0 minus x squared is minus x squared. Bring down Okay, so x times y is minus x squared, minus x. Then I'm going to multiply minus x squared minus x. Take away 0. 0 minus minus, I get plus x here. Bring down, plus 2. Multiply, this is going to be plus 1. X times what is x? 1x plus 1. So I'm going to get 0. 2 minus 1 is 1. So now this becomes the integral of x squared minus x plus 1 over x plus 1 with respect to x. Okay? So when I integrate this, I'm going to have x cubed over 3 minus x squared over 2 plus x plus ln of x plus 1 plus c. Exactly. They'd ask them exactly like this. Find the integral of this. They would not mention they are top heavy, no. Okay. So this is the end of 6E partial fractions. There is a bit of an extension question here, which is quite nice. I'm just going to give you a clue. All they've done with this, and you might be thinking, why have they written dx like this? Guys, remember, 1 over x plus x cubed multiplied by dx over 1. Okay, it's just another way of writing 1 over x plus x cubed with respect to x. Okay, so please, like, always think simple, yeah? Maybe give that a go. So, differential equations. This is now going to help us with when we look at rates of change. This is normally the second part of the question. So, it wants us to find a general solution to this equation. dy over dx equals xy plus y. So, dy over dx equals xy plus y. So we have to find the general solution to this equation, right? You're probably looking at this thinking, where on earth do I go from here? Okay, this is what our step 1 is. So we have a few simple rules to follow. Now, before we look into the hows, the whys, and looking into the application of the questions, we're just going to look at the rules. Are we ready for the rules? Yeah. Rules are as follows. You want to rearrange your equation so your y's are on the same side as the dy by dx, and everything else is then on the other side. Okay? So, here we go. I'm going to get dy by dx equals y lots of x plus 1. Okay? So then, however, I'm going to get dy by dx divided by y equals x plus 1. Okay. Let's rechange this to get 1 over y dy by dx equals x plus 1. Okay, step 1. Is everyone happy? We have y's on one side with the dy by dx and everything else on the other. Yeah. Step 2. We multiply both sides by dx. So we have 1 over y dy equals x plus 1 dx. All I've done technically? Okay? Multiplied both sides by dx. Okay, now you're probably thinking, well, where do we go from here? Technically, how could we get rid of a dx? We now are going to integrate both sides. This is crazy. I know. So what's the integral of 1 over y? Ln of y. Okay? Equals, what's the integral of x? X squared over 2. What's the integral of 1? X. And then plus c. The y never disappeared. We integrated it. Of course. When we integrate, what normally happens? Okay? Right. Oh, and then the final step is to rearrange it into the form y equals. How would we now get y equals? Yeah, we e both sides, right? So we're going to get e to the x squared over 2 plus x plus c. Everyone happy with this? However, we're not going to leave it in this form, and this is why. Because this is technically the same as y equals e to the x squared over 2 plus x times e to the c, right? Which is like our constant. Okay? Now, we've just got to be careful with this constant. When we have this now, it's typical to write it as, now don't ask me why we do this, but if we have an e to the c as our constant, we write it as a to the e of x squared plus 2 plus x. Okay?
Doesn't make sense.
Because, first of all, this is what does make sense. When we add indices, that's the same as multiplying them too. So we can split it up like this, right? However, remember, e to the power of c is our constant. Instead of writing e to the power of c, because e to the power of c is technically a number, it doesn't involve the x, right? Instead of writing e to the power of c, their constant of integration is now called a. Okay?
Like the default.
Yeah, this is a default. Okay, so there we have it. We've done it. So here's another example, okay? Okay, so I'm just going to bring it over here. So I have 1 plus x squared dy by dx equals x tan y. And some of you are probably thinking, how do I even know to use this method? It will literally say, find the general solution to this. If you've got dx dy and you've got y's and x's, you know this is a differential equation, okay? So remember, right now we're just going through the motion of the steps. Step 1. Technically, you want your y's on the same side as your dy by dx. So I want my tan y and my dy by dx on the same side. Okay, so now we're going to have, if we divide both sides by 1 plus x squared, dy by dx equals x tan y over 1 plus x squared. Okay, now I need to do what to both sides? Divide by tan y. So 1 over tan y dy by dx equals x over 1 plus x squared. Okay, now my y's and my dy by dx on one side. Yeah, I got my y, dy by dx, everything else is on the other side, right? Okay, we now move on to the second phase, which is multiply both sides by dx. So I now get 1 over tan y dy equals x over 1 plus x squared dx. This now should prompt me to realize, how do I get rid of the dx dy? I integrate both sides. Okay, someone needs a formula book because I'm pretty sure the integral of tan y. Okay, so guys, let's think about this. 1 over something integrated gives me ln of whatever's here, right? Tan y. Then we're going to divide by the differential of tan y. Is it sec squared? Sec squared y. I have no idea. I'm trusting you guys here. So this equals, how do I integrate x over 1 plus x squared? What should I do? Partial fractions. We can't separate them. The only problem is now is we have like this random function.
No, didn't we do this? This would be like the product thing.
So you're saying that this is x ln 1 plus x squared modulus divided by 2x plus c.
You just said that wasn't allowed.
Okay. Okay, so we know this is completely wrong, and again, you know, this is sound, and this is where the hard part of integration comes in, is because we know we're wrong here, because we're not going to be able to manipulate this to get y. So, what do they do in Japan? No. Okay. So, let's have a look at 1 over tan y with respect to y. And let's just do one side first. We know that this is the same as the integral of cot y with respect to y, because we know 1 over tan is cot. Now, in the formula book, okay, and this is why sometimes you don't remember this, is in the formula book. Your formula book for Pure 4 is going to be your best friend. In the formula book, it tells you the integral of cot x is ln of sine x. So we actually, this becomes ln of sine y. This is better because technically now I just have a ln, so it means I can e the other side. Yeah? Okay? Are we happy with this? Brilliant. Okay, and are we happy with the integration of the right-hand side?
This is that actually like.
Are we happy with x over 1 plus x squared?
No.
Yes or no?
Yeah, we're fine. The right side is fine.
Okay.
I want to do this.
So,
I need to know.
the right-hand side is correct. This one is fine. Okay? Okay. So, x over 1 plus x squared equals x ln of 1 plus x squared over 2x.
No. It's just. Yeah, exactly. So I was right.
The x's are going to cancel,
Exactly.
which gives us a half ln of 1 plus x squared. Okay, guys, plus c. And this is ln of sine y. Now, before we e both sides, what would be a practical thing to do? Get rid of the half. So we're going to get ln of the modulus of root 1 plus x squared plus c. Now what we're going to have is ln of sine y. Now you guys are going to... Now this is where people make the biggest mistakes. Okay, so when we e both sides, the best way to do this is if we have ln of something equals ln of something. Currently, we have ln of something plus c. Now, c is a constant, okay? So technically, we could even say that this is ln of c. Is ln of c still a constant? Then if we add them together, we now get c, because the ln rules, you know, the log laws, 2 logs added together is actually the insides multiplied, right? So we're going to get c root 1 plus x squared. Now, they use a k in certain things. Then we get sine y. Now we can e both sides to get sine y equals c root 1 plus x squared. So y equals arc sine of c square root 1 plus x squared. So here, I know we've said ln c, however, in the exam, you should do c equals ln of k. And then if you made a mistake like I did then, you can just make it look like a k.
That's the answer.
Okay, I know. Perfect. So we can see here that if possible, we always want to try and combine our constant of integration with other terms. Okay, this is what the aim is to do, is to try and get that constant of integration combined with the other terms. Okay, so now, differential equation with boundaries, you do everything exactly the same. However, we're going to have some boundaries, okay? So, are we ready to give this a go? So what you're going to do is everything exactly the same, all the steps we've just been doing, and then when you get to the stage where you have y equals something, that's when I'm then going to introduce these boundaries to you, and we're going to have a look at that. So give this a go. Okay, so for this one, I would suggest cross-multiply straight away, right? So if we cross-multiply this way, remember there's a negative, yeah? So what are we going to have? We're going to have 1 over 3y minus 6 equals negative 1 over 2x plus 1, x plus 2 with respect to x. Sorry, dy here. Okay, so we should have done this first.
And this you get 1 over dx.
Yeah?
The left side is correct, the right side.
No, because we cross multiply. I multiplied dx up here. I brought this down here. Dx up there.
Yeah, I did the same.
So if you multiply both sides by dx, it's going to cancel on this side. Yeah? Okay, so we should get to the stage. Now what do? We are going to integrate both sides, okay? So if we focus on the left-hand side first, what is the integral of 1 over something? Ln of the modulus, and then divided by what? 3, because it's the differential of the bracket. Okay, guys, remember, this is going back to pure free and now. So you really need to be 100% set on all of this. Okay, this equals. Okay, with this side, can I integrate this as it stands right now? No. What do I need to use? Partial fractions. Please tell me no one in the room integrated this. Okay, so partial fractions. How would I split this into partial fractions? We know that minus 1, oops, what happened there? We know that minus 1 equals a lots of x plus 2 plus b lots of 2x plus 1. So if we substitute in x equals negative 2, I'm going to get minus 1 equals negative 3b. So b equals a third. Okay, then if I substitute in x equals negative a half, I get minus 1 equals 3 over 2a. So a equals negative 2/3. Yeah? So therefore, that means I'm technically integrating minus 2 over 3 lots of 2x plus 1 plus 1 over 3 lots of x plus 2. Everyone happy with that? With respect to x. Okay, so now if we integrate this, it's better for us. Now, in the answer, they've simplified this. However, we're going to have 6x plus 3 plus 1 over 3x plus 6 with respect to x. Okay, so when we integrate this, we're going to end up with lns, right?
Yes.
So we're going to have minus 2 ln of 6x plus 3 divided by the differential of the bracket, which is 6, plus ln of 3x plus 6 divided by the differential of the bracket, 3 plus c. Sorry. Okay, so now what's going to happen is, let's tidy this up. So I'm going to have ln of 3y minus 6 cubed, because, sorry, not cubed, cube root, equals minus a third. So I'm going to change this the other way round. So I'm going to have ln of 3x plus 6 to the power of a third, okay, minus 2 over 6 is what? A third as well. So minus ln of 6x plus 3 to the power of a third plus c. Now remember, we need to make this all ln something. So this is going to stay the same. We're going to get equals ln of modulus 3x plus 6 to the power of a third over 6x plus 3 to the power of a third plus c. Now what am I trying to do with this plus c now? Yeah, so I'm going to say let c equal ln of k. So if c equals ln of k, this is technically ln of k lots of 3x plus 6 to the power of a third over 6x plus 3 to the power of a third. Now technically, guys, and then I'm going to get ln of 3y minus 6, oh my, third. Okay, so now I've got ln's on both sides. Now what am I going to do? E both sides. So I now get 3y minus 6 to the power of a third equals k lots of 3x plus 6. Now I've done this step by step. Like, this is tedious writing this all out, but it's just to make sure we're all on the same path, yeah? Okay, now I need to rearrange to get y. So what am I going to do to both sides? Everything. Cube it. So 3y minus 6 equals technically k cubed, right? K cubed is still a constant, so you don't actually technically have to write k cubed, okay? But we are cubing everything. 3x plus 6 over 6x plus 3. We're now going to get 3y equals k lots of 3x plus 6 over 6x plus 3 plus 6. So now what? We're going to divide everything by 3. So, y equals.
You can simplify the fraction first.
Yeah, have you multiplied it all by k though?
I don't have to.
You've taken out, if we take out a factor of 3. Okay, so let's do this first then. This is going to become 2 and 2x plus 1, right?
Yeah.
So now I'm going to have k lots of x plus 2 over 2x plus 1. What is this divided by 3? We get a 3 up here. Is that right? No. 3 down there. Plus 6 divided by 3? 2. So my final answer is y equals k lots of x plus 2 over 6x plus 3 plus 2. Now, they've told us that when x equals 1, y equals 4. So this is just like substituting, and we technically need to find k now. When x equals 1, what does y equal? 4. So we know that 4 equals k lots of 3 over 9 plus 2. So 4 equals a third k plus 2. 2 equals a third k. What does k equal? 6. Okay, guys, so test your understanding. Let's do this question together. I'll give you a few minutes and then we'll go through it. So off you go. So this is a core 4 exam question. So given that y equals 2 at x equals pi over 4, solve the differential equation. So this means that when we integrate, we're going to have to then get a plus c, and then we're going to have to substitute these values in to get y equals. It's just a classic. Do you remember when we used to do the questions where you used to have to find the equation of the line, you get given a coordinate like that? This is exactly the same apart from the differential. So remember, step 1. So let's just rewrite it over here. So dy by dx equals 3 over y cos squared x. Okay, remember, we want y's on one side, everything else on the other. Okay? So I can multiply both sides by y. So y dx, y dy, and divide and multiply both sides by dx, right? Equals 3 over cos x squared with respect to x. Okay, so now I have it. Sorry, cos squared with respect to x. Now I have it in the form I want to integrate. So if I integrate y, this becomes y squared divided by 2, or a half y squared, okay? Then, can I integrate this straight away? No. Okay? What is cos squared? What is 1 over cos squared? Sec squared. So this becomes 3 sec squared with respect to x. Now guys, sec squared is in the formula sheet. Okay? So the integral of sec squared x is tan x. So this becomes 3 tan x plus c. So now I've done this properly. I need to substitute in 2 and pi over 4. So I'm going to get half lots of 2 squared equals 3 tan pi over 4. My calculator needs to be in radians, okay? So I'm going to get 2 minus, what is tan of pi over 4? 3 lots of something equals c. Quickly. 1. So 2 minus 3 equals c, so c equals -1. So now that c equals -1, we know that a half y squared equals 3 tan of x plus c, but our plus c is -1. How do I rearrange this to get y equals now? Multiply both sides by 2, so I'm going to get 6 tan x minus 2. And then how do I get rid of the square? Square root it. 6 tan of x minus 2. Okay? Now, maybe just put plus or minus as well. Okay? So, in the mark scheme, I think we can leave it just as y squared. We don't have to do y. However, it just says, given this, solve that. So we could even leave it like this, really, on this stage here. Okay? So the mark scheme you can see here, you can leave it like this. You don't even have to rearrange to get y equals, and then they've put or equivalent. Okay? Okay, and then some key points on differential equations. Remember, okay, there's some stuff here. I'm not sure. Right, we just know that if it's dy by dx, we want y's and dy's on one side and x's and dx's on the other. That's when we know when we're integrating. Now, when we integrate, please watch out for trig functions, partial fractions. Remember, 1 over x minus 2 all squared is not a ln, okay? Because it's technically to the power of minus 2, yeah? Okay, then you need to remember as well that if you do have lns, make sure your constant c is then equal to ln k, yeah? Or if you have the e's to the c, call that a. Or you can just call it k again if you want. But this kind of thing, okay? Just remember that kind of stuff, and yeah, you'll be perfect. Well done. Okay, so summary of functions and how to deal with them. This is created by Dr. Frost. I think these are really good, and I'll just pause it on the next few slides. I'll leave them all blank. Yeah, so just pause here, have a read through. Again, there's more functions now. Maybe try and have a guess. Yeah, so here we go. Have a look at what you would do here. Again, here are some functions. Have a guess on how you deal with them first before we have a look. Brilliant. And there you go. So thank you for watching. Have a wonderful day.